Okay, so create a linear system to model this situation. In Calgary, a school raised $195 by collecting 3,000 items for recycling. That's the first one. Let's read the whole thing first. The school received 5 cents for each pop can and 20 cents for each large plastic bottle. Okay? So I guess what we're trying to find out here, we're trying to set up a system where we have pop cans and bottles, right? So they're collecting a number of them, and there's also a price, a price that you get for these recycled items. So we're going to let's let P be pop cans. Because remember, we have to identify our variables first in order to make an equation. And let's say B is bottles. How about that? Okay. P is pop cans, B is bottles. So this first part, they raised money by collecting 3,000 items for recycling. Okay. Now this one's a bit tricky because we've got a money value here and from a number of items. Now notice the money value is down in the second part. So actually this money value is going to be related to the cost or the revenue for each bottle. So the 195 doesn't go in the first equation. Okay? But instead the first equation has to come from this, 3,000 items. So 3,000 items is the total when you add together all of the pop cans and all of the bottles. Right? So we'll save the money one. This is why kind of money is a bit tricky. The money stuff all go together for one equation, and then the other equation is just simply the number of items. So how would I write an equation if I want to say that in total the kids collected 3,000 pop cans and bottles? What would that equation look like? Anybody want to venture a guess? It's a very simple equation. I get 3,000 items from the number of pop cans and the number of bottles. That's my first simple equation. Okay? I know that seems like too easy. But pop cans, the number of pop cans plus the number of bottles, plastic bottles, is 3,000. That's our first one. Second one. Now the second one deals with the money. Okay? We get the kids got $195 for the pop cans and bottles, and this was the price that was attached to each of them. Okay? So when we're dealing with money, here we've got 195 is the total number of dollars. Okay? So I'll put the little units there so we remember. And that comes from 5 cents for each pop can. So when we have 5 cents for each pop can, we're going to multiply P times the money value. Now this is in dollars, so guess what? The number that I put here has to be in dollars as well. How do I represent 5 cents as dollars? 0.05? Does that sound good? 5 cents? That's $0.05, yes? We're good with that? Okay. And 20 cents for each large plastic bottle. So the bottles, we get 20 cents. So what's 20 cents in dollar form? Yeah, $0.2. Good. Everyone see that? So these are the two equations, and you know what? It's just going to take some time and practice. And you might write two equations that aren't quite right sometimes, but that's okay. You try and you fail, and you try and you fail, and then you try and succeed. Okay? So these are the two equations. The money stuff, keep all the money stuff together in one equation if possible. That's a hint for you. Okay? So there's our system. The second part says, let's test. The school collected 2,700 pop cans and 300 plastic bottles. Let's see if that fits both equations. All right? So I'm going to take this equation, just move it over. Okay? So let's test that number to see. So 2,700 pop cans. So 2,700 would go where the P goes. The 300 would go where the B goes. Does that equal 3,000? It sure does. 2,700 plus 300, 3,000. That one's good on that side. Now let's check those numbers to see if that makes our other equation true. So 0.05 times 2,700 plus 0.20 times 300. Does that equal 195? And here's where you get your calculator out if you need to, and you go ahead and do that. So 2,700 times 0.05, that's going to give us the dollar amount for the pop cans, 135. And then the dollar amount for the bottles is going to be 300 times 0.2, 60. Okay? Does that equal 195? It sure does. Okay? So use your system to verify that this is the right number of pop cans and bottles, and we've done that. All right? So that's how you do a question like that when you come across it in your assignment.